The last two types of equations we're going to look at are absolute value and radical. Starting off with our absolute value equations, you want to isolate the absolute value first. So I'll add the 20 to both sides and then divide by 4. Once you have the absolute value isolated, remember that an absolute value is distance from 0, so it makes whatever's inside the absolute value positive, which means what's inside the absolute value could be negative. So our next step is to set what's inside the absolute value to both a positive or a negative, and then solve each of those equations individually. Starting off with the left-hand equation, subtracting 1 from both sides and not losing my negative sign, dividing by -2. Same thing on the right equation, subtracting that 1 and dividing by -2. So we have two possible solutions for our absolute value equation. Next, solving radicals. Similar to absolute value, you want to isolate the radical, dividing both sides by 4, and then square both sides. Finally, add 3. For part B, we still want to isolate the radical. This time we have 5 minus x. We have a binomial on the right-hand side. So when we square both sides, we cannot square each piece individually. Remember, squaring means multiply it by itself. So we'll have to FOIL on the right-hand side. Our left-hand side is simplified, so we're going to leave that alone for now. 5 times 5 gives us 25. Negative 5x plus negative 5x gives us a total of negative 10x. And the negative x times negative x is a positive x squared. We ended up with a quadratic equation on this one, so we want to set it equal to 0 and see if we can factor or use the quadratic formula. Because the x squared is positive on the right-hand side, I'm going to subtract the 31 and add the 9x. I'm also going to rearrange and write it with the x squared on the left. So we've got negative 10x plus 9x and 25 minus 31. I always check for factoring first before I use quadratic formula, especially t-chart. It's much faster to get it factored and then solve. What multiplies to a -6 and adds to a -1 would be -3 and +2. Finally, setting each binomial equal to 0, either x minus 3 is 0 or x plus 2 is 0. Solving each equation, we get x equals 3 or x equals -2. With radicals, it's important to check for an extraneous solution. I forgot to do that on the first one, but let's check on this one and make sure neither of those values makes what's under the radical negative. 31 minus 9 times 3 would be 31 minus 27. That is positive, so we're good. 31 minus 9 times -2 would be 31 plus 18, which is positive, so we're good on both solutions for this one. Let's scroll back up and double check A. If we put 7 under the radical, 7 minus 3 is positive, so that works as well. And your 2 U-try questions.